Welcome to the next optimization problem. So this one's in your notes. A window is in the shape of a rectangle surmounted by a semicircle. That just means a rectangle with a semicircle on top. Find the dimensions when the perimeter is 12 meters and the area is as large as possible. So we want to maximize the light coming into the room. So we want the area to be as large as of this window to be as large as possible. All right, so I have a picture of a diagram drawn there of our window. So it's a rectangle. Right, two dimensions of a rectangle, length and width. And the semicircle is exactly on top. And if we look, we notice that the distance across the circle, which is the diameter, is the same as the length of the rectangle. Right, and so that means the diameter is the same as length. We don't work with diameter when we're dealing with area. We need radius. So if length is the diameter, radius is half a diameter, so that means that the radius is half the length. All right, so we want to maximize the area, and the area, come on, there we go, area of our window is the rectangle. And so, by the way, this is going to be our primary equation once we got variables in there. Area is the rectangle, area of the rectangle, I guess I should say. Plus area of semicircle. Now I reoriented the board, but you wouldn't know it by the way that area looks. I think that's as good as it's going to look. All right, so the area of a rectangle is length times width. The area of a circle would be pi r squared. So the area of half a circle would be pi r squared divided by 2. And you can see we have way too many variables in there. Right? We can replace one of them pretty easily, and that's the radius, r, with half a length. Right? So let's do that. Right? So area equals LW plus pi, and then half an L divided by 2. So L, actually, you know what? Let me write this at the end. Let's replace the W too. Let's replace both things at the same time. But anyway, we've got what we need to replace the R. Now let's figure out how to replace the W. All right. Well, we're given some information, and that is our constraint. And whoops, I have no idea how that came up. The constraint is that the perimeter has to be 12 meters. So the perimeter is the distance around. Right? So the perimeter is the length plus the two W's, two widths, plus the circumference of a semicircle. Well, the circumference of a circle is 2 pi r, so the circumference of a semicircle is pi r. And we are given that the perimeter has to be 12 meters. I need to get rid of that box. That kind of bothers me. Will it go away? Yes. All right, so we have 12 equals length plus 2w plus, right, so instead of 2 pi r, we have pi r. Oops, why did I put a 2? Pi r. And then we can replace the r with half an L. So then we have 12 equals L plus 2w plus pi and L divided by 2. There we got half an L there and there. All right, so let's isolate the 2w because that would be the easiest to deal with because we've got two L's in here. So we have 12 minus L minus pi L divided by 2 equals 2w. And then if we divide everything by 2, we'll have just a w, so we can replace the w in that equation. So now we have 6, right? Half of 12 would be 6, minus L divided by 2, minus pi L now divided by 4, right, equals w. All right, so now let's replace everything into our new equation. And we're going to be left with a bunch of L's, so let's call it A of L. A of L equals the length, and then W is now 6 minus L divided by 2 minus pi L divided by 4. And then plus, let me fix that. That looks like I don't even know what to call it. That was an L. And then plus we've got to substitute half an L, right, for the R. So we've got pi, we've got half an L squared divided by 2. All right, we really want to simplify that. I don't want to take no derivatives of that equation without simplifying first. So A of L equals, all right, so we'll multiply everything by the L here. That's a parentheses here. So we have 6L minus, this would be L squared divided by 2 minus pi L squared divided by 4. Got a lot of stuff to this equation. And then plus, so that would be pi, and that would be 1/4 L divided by 2. We can, by the way, move that 4 down into the denominator. Because if you think about it, if we multiply the numerator and the denominator by 4, right, the 4 in the numerator would cancel, and the 4 in the denominator would be, the 2 in the denominator would then be an 8. So let's do that. So A of L equals 6L minus L squared divided by 2 minus pi L squared divided by 4 plus pi L divided by 8. And none of these terms are like terms, so we can't combine anything. But now we can take the derivative and find our critical points, right? So let's find the critical points, because now we're down, all of that was just to get this down to one variable, one independent variable. So now find the critical points. All right, so we got A prime of L equals, that would be a 6 minus, all right, so that would be a 2L. That's going to cancel out the 2, and that's just going to leave an L, right? The derivative of 2L divided by 2, or excuse me, L squared divided by 2 would be 2L divided by 2, which is just L. Minus, so now we're going to have 2 pi L divided by 4, so that's pi L divided by 2. And then we have plus pi 8s. Oops, oh, you know what? I'm sorry. Somehow, over here, we lost the square. I squared the 1/2, and I left the square off the L. So this should be an L squared. I knew something didn't look right about that. So then we'd have 2 pi L divided by 8. That would be pi L. Oh, now we could have added those two terms. Look at that. These were like terms. Now that I see I accidentally left the square off, but that's okay. We'll just simplify it now. There's no point going back and simplifying it and then taking the derivative since we're on the last term. So this would be pi L fourths. Let's combine the like terms. So A prime of L equals 6 minus L, and then, so this would be, so pi L halves is the same as 2 pi L fourths. So negative 2 pi L fourths plus pi L fourths is going to be minus, right, pi L fourths. All right, so now we'll set that equal to 0. Now that's looking much better. We had a lot of terms before. So we have 0 equals 6 minus pi L fourths. Let us move the pi L fourths. So pi L fourths equals, oops, did I lose something? Yes, what is it? I don't like one term. Yeah, it's a lot easier when you leave off a term. 6 minus L minus pi L fourths. All right. Now, that's not as pretty to solve, is it? All right, let's see what we can do about that one. All right. It's that pi, it's the problem. So we got 0 equals 6 minus L minus pi L fourths. Well, we don't have to deal with that pi fourths, do we? Let's get a decimal equivalent. All right, so then we can combine the terms, right? Because L is to the exact same power. All right, so pi L fourths is approximately 0.7, so that's 0.785398. Right, we have to do that. We can't have the exact number because otherwise we're going to be sitting here with nothing to do because won't be able to solve it. So 0.785 398L. Okay, so now we can combine like terms. We can move and we'll move it over to the other side. All right, so we have, if we add that together, the two negatives there, we're going to have 6 equals, actually I'll put this one over here. We'll have 1.785398L, right, because we can combine those two negatives, and we're just going to add it to their side, equals 6. And if we divide 6 by, L. If we divide 6 by that value, L is going to be equal to 3.360595. 3.360595. I have to lean over to the calculator, which is on the table. 360595. There we go. All right, so that's our critical value right there. All right, so now let's test in a sign chart. All right, so here's our sign chart. And this is for the first derivative. All right, so there's our critical point, 3.360595. Let's use a value less, like 1, and a value more, like 4. And if we plug that back into the original equation, so I've got, and I'll use a calculator, we got 6 minus, the original derivative when I say equation, so 6 minus, so this is L, right, so 6 minus 1, and then minus pi divided by 4. And that gives us a positive number. And if we plug 4 in, we've got 6 minus 4 minus 4 pi divided by, 4 pi divided by 4. That's just going to be pi. Well, except I put parentheses in. I'll have to continue to put the parentheses. And that gives us a negative number. Actually, we'll be able to figure that out because pi is 3.14. And so that'd be 6 minus 7.14. Of course, that's negative. Duh. All right, so L equals 3.360595 is a relative max because f prime, oops, not f prime of x, it was a prime of L. Gotta make sure you use the right variables. A prime of L changes sign from positive to negative let's just write it at this value. It's kind of a long value. All right, so now let's verify that with the second derivative test. All right. All right, so let's take the second derivative and where's our second derivative? How about after we've combined the terms? All right, so a prime of L is 6 minus L minus pi L fourths. All right, so that means a double prime of L equals, so derivative of 6 is 0. Derivative of negative L would be negative 1. And then the derivative of the pi L fourths would be minus pi fourths. Right? That's just to the first power, so it's just going to be the coefficients, and that's clearly a negative number. All right, so let's get a little bit more space. So, since a double prime of that number, because there's nothing to plug into, right? So a double prime of 3.360595 is less than 0. I have to write that again. L equals 3.360595 is a relative, is a relative max, yes. And I'm just going to put in parentheses, a double prime, or a of x is concave down everywhere, or a of L, excuse me, is concave down on the domain. There, we got that taken care of. Further verifying that this is a relative max. All right, so now all we got to do is find the dimensions. All right, so last thing, area of the window is maximized when the length equals, and this was in meters. The length equals 3.360595 meters. And then we need to plug back into the other variables to find out what they should be. This one took a little longer, probably because of the solving. Let's see, radius was half an L. So just divide that by half. Radius of the semicircle equals, so 3.360595 divided by 2, 1.6, it's dark in here, 1.6802975. And width probably should have done length then width, but the equation for radius was really easy. And I can see width up there. So width would equal 6 minus 1.680297.5, and then minus pi 3.360595 divided by 4. Or let's find out how much that is. So 6 minus my previous answer, and then minus, let's see, I can do, if I do pi times my previous answer, so I don't have to keep typing that in, divided by 2. Right, so I just did the 1.680297.5 is length divided by 2. So I just used that number again and just divided it, instead of divided by 4, divided by 2. So the width is going to be 1.6802, I'll use as many variables, 97 meters. And there we go. That's the end of this problem. I have only one more problem left, and that's probably my quickest problem of all. All right, so bye for now.